1 minute.
A good Tuesday afternoon and welcome to what is the very last week of World of Weather. And this week, Chief Meteorologist Jennifer Valdez and I are going to be going through some of the things that we do behind the scenes from what we're talking about today, which is forecasting, to how we actually get our forecasts on TV and everything that goes on behind the scenes here at CBS 46. So today we're starting with forecasting. And as a meteorologist, I went to school for a very long time to learn how to forecast. It involves a lot of math and a lot of science, but this is just the basics of what we do. Every single day when I come in, I spend about an hour or two forecasting, depending on the forecast. If it's a tougher weather situation, if it's more difficult, I spend anywhere from 2 to 3 hours on producing a forecast that you only see for maybe 2 to 3 minutes at a time. So that's a lot of time for just a very small amount of time on air. And this is my forecast sheet that I made for yesterday. Yesterday was a fairly simple forecast, so there's not a whole lot on here, but every single one of these numbers we come up with ourselves. We don't read anything else. We don't take the forecast from anywhere. We come up with the forecasts ourselves. And I know that's a pretty common misconception when it comes to TV and watching someone do the weather on TV. But everyone here on staff went to school for a long time to become a meteorologist. So let's talk about how we forecast. And at its most basic, we look at the atmosphere like it is a piece of cake, because it's got several different layers to it. You've got your highest levels, your upper air, your part of the atmosphere, and then you've got your lowest levels, which is where we are down by the surface. And every single layer plays a very important part. And I wish forecasting was this easy. I wish it was a piece of cake, but there's a lot that goes into it. So one of the first things that we do when we start forecasting is we look at what is happening right now. What is happening right now? What temperature is it? What is the dew point? How much moisture do we have outside? Is it raining? Did our forecast pan out from yesterday? What is happening right now? And one of the ways that we get that information is from something called a weather balloon. The National Weather Service releases these balloons every single day up into the atmosphere, and this is what we get back. It's a lot of data, it's a lot of numbers, but we analyze these to find out what's going on in the atmosphere right now. And another thing that we look at is what's going on from satellites. What can we see cloud cover wise? You know, how much cloud cover do we have? That really affects temperatures a lot. And you can also see a bunch of different things on satellite, like temperature and moisture and so on. Water vapor is a big thing on satellite too. So this is actually a satellite image that I just put into our computer. This is what it looks like right now over Georgia. I know it's hard to tell exactly where Georgia is on here. And I guess I could have used the satellite from our actual weather computers. This is from a different website. Georgia is about right here, and you can see just how much cloud cover we have today. It is gloomy, and because we have so much cloud cover, our temperatures are actually cooler than what we saw over the weekend. Now, our next step, once we figure out what is happening right now, that's when we dive into what is going to be happening in the future. Let me get that box off there. There we go. What is going to be happening in the future? And how we do that is we look at several different weather models. There are a bunch of different weather models out there, and probably the most famous one that you hear about a lot is the European model, and that's because it made that very famous prediction with Superstorm Sandy a couple of years ago, where it was the only model about 8 or 9 days out that was predicting that it was going to turn back towards the United States and hit the eastern seaboard. None of the other models were saying that. And eventually they all came into line. And the reason that we have different models is because different things are put into different models, different things that you start with. If you start with, let's go back to our piece of cake and put this in kind of the dessert realm. If you guys can't tell, I'm kind of hungry right now. So if you have the materials to make a piece of cake, or you have the ingredients to make a cake, what you're going to come out with is a cake. But if you have the ingredients to make a cookie, you're going to come out with cookie. Now, there are some similar ingredients in there, but they're different outcomes. And that's what you have when you have weather models. You have similar ingredients. You have temperatures that are going in there. Satellite data is going in there. A lot of different things, but there's some minor differences that produce different outcomes with different models. And not one does a meteorologist rely on it as their forecast. We look at all of them and kind of take everything into account of each one is saying, and then we produce our forecast. So when you see just, especially during hurricane season, since now we're getting really close to hurricane season, when you see someone post a picture of just one model of the hurricane doing one thing, that's why it's really, really hard to rely on that, because there's so many different things that go into so many different models. So let's continue on as we get into, I actually want to pull up the map first before we get into high and low pressures. Actually, we'll do this first. High pressure. So one thing that we do when we're analyzing those models is what are the big weather features and where are they moving? And so we look at its most basic, some things like high pressure, low pressure, where are the fronts? Where are the cold fronts? Where are the warm fronts? And are they moving in our direction? So when you see high pressure, it's that big H on the map. You see it quite a bit if you watch CBS 46. That is high pressure, and that is spinning clockwise. And that usually means that we're going to have some clear and some dry weather. Another thing that it means, especially in the summertime, as we get into that, well, basically we already are in the summertime here in Georgia. It's been kind of hot lately. But when you see this big H that settles over the southeast, a lot of times that indicates that our pattern is stuck and we are going to be in a summer heat wave. And actually it's called a heat dome sometimes, when it just sits and just spins over the southeast. And then things really start to heat up because you've got all that sinking air with the high pressure that clears out our skies and keeps us dry and keeps us very hot in the summertime. Now, what we're dealing with and what we dealt with last week is low pressure. There's a big L on the map. It spins counterclockwise, and a lot of times that's associated with some unsettled weather. Last week, we had a big low pressure system that just sat and spun over the southeast for a couple of days, and that's why we saw daily rain chances last week. And a lot of times these are associated with some storms. They're associated with cold fronts too. So let's talk about cold fronts since we're right here. Cold fronts, and we'll show them again in a second, but of course, if you watch CBS 46, if you watch the weather frequently, you've seen us point out cold fronts a lot. It's the blue line with the triangles. What's happening is you have cold air moving, and it's forcing the warm air up over that front because warm air rises, and sometimes within that you get those showers and thunderstorms. Not every cold front brings rain. Sometimes we have dry cold fronts. It just depends on how much moisture and some of the other atmospheric properties that are working all together to make weather happen. So this is our weather map today. And I pulled this from the National Weather Service website, and you can see some of the things that are happening. I know this is kind of hard to see because it's kind of far away, but I'm going to step back so I can point some things out. We have a big low pressure area that's across Florida right now. That's actually, it's a little bit of a tropical low pressure. It's not going to become a tropical system, but that's lifting to the north in our direction. And that's why we have so much rain today. It's why we're going to see so much rain tomorrow. But there's two factors at play here, actually, because we have a cold front that's just off to our west. As that pushes towards us, it's going to combine with some of that tropical moisture. And that's why we have so much rain this week, and it just won't go away. So there's lots of things that are at play. There's lots of things that we look at when we forecast, and that is the short-term forecast. And something, it's a fact that I love, of course, because I forecast every single day, is I'm so proud of this science because meteorology has come a long, long way in a very short amount of time. 5-day forecasts are about 90% accurate. Now, when you get to 7-day forecasts, you lose a little bit of that accuracy and you get to about 80% accuracy for days 6 and 7. But the meteorology science has become a lot more precise over the past couple of years, and we've gotten it down to, within the first 5 days of the forecast that you see here on CBS 46, it is about 90% accurate, and that is incredible when you base it on where we came from. And that also falls in the realm of tornadoes and severe weather. The tornado lead time, the time that we can give people to warn them that a tornado is coming in their direction, has become a lot longer over the years. Just in about 20 years, I think the average lead time is somewhere between 8 and 9 minutes. That might, I believe I read that somewhere. It could be a little bit different, but certainly there used to not be a lot of lead time at all for tornado warnings and tornadoes. So we've come a long, long way with the science of meteorology. Now, one thing that we're still working on, because it's not a perfect science, it never will be a perfect science because you're predicting the future. And one thing that we are working on is long-range forecasting. When you talk about snowfall, when you talk about hurricanes, we see those hurricanes coming from a long way out, sometimes in the Atlantic, and we're watching them for 1 to 2 weeks. That's when you start to get into the long-range forecasting, and that's where things become a little less accurate. But there's lots of reasons why that we see that accuracy kind of fall off just a little bit. So you think of it, if you watch The Price is Right, this is just like the game of Plinko. Price is Right, I think they played it on Price is Right today, if I'm remembering correctly. So you have at the very top, the little, I guess the disc that you drop into the Plinko. That's our current conditions. And down here, you have all of the forecast possibilities. And this particular instance is talking about snow. And I know snow, notoriously hard to predict in Georgia, and this is one of the reasons why we're going to explain. So you have your current conditions up here, and then you have anywhere from 0 to 12 inches of snow, back to 1 inches of snow, 8, 4, it could be any of these possibilities. Here, we're talking about 10 days before potentially snow coming our way, and then day 1 is all the way down here when you get closer to the actual amounts. So let's fast forward this just a little bit. And you see people do this on The Price is Right because they're trying to get the highest money amounts that are at the bottom. There are so many different paths that this can take. And depending on which path it takes is the result that you're going to end up with. And that's really hard to see from 10 days out exactly the path that it's going to take. And despite all of the possibilities, all of the different paths that this can take, the models that we talked about only give you one solution, and that's why you can't trust just one model. So what happens is as you drop that disc, one small deviation, one small change, if it hits one of these pegs, it's going to make a big difference in the result of the outcome. And that's why when we make these predictions several days out, you see the forecast change quite a bit. Again, it's not a perfect science. It never will be, but it's gotten so much better over the past couple of years. The closer to the actual day, the fewer paths that this actual disc can take. And so you start to narrow in on your forecast. And then, of course, around day 1 or day 2, from the actual event happening, that's when you start to get a really, really, really good idea of what's going to happen. So long-range forecasting is certainly more challenging, but for me as a meteorologist, that's what makes it the most fun, and it does make it, the challenge itself is very exciting. Another way to think of this, if you're not familiar with Plinko, and I actually had a college professor tell me this at UGA, and it's really stuck with me because I think it's just a great, great way to think about it, is if you have a river and you drop a stick in at the top of the river, at the beginning of the river, and you go down to the end of the river, can you say exactly where that stick is going to end up? You know it's going to end up down there, but exactly where it's going to end up, you'll have a better idea when it gets closer to the end of the river. And that's pretty much what we do in forecasting at its most basic. So I'm going to talk to my producer, Mia. Do we have any questions? I know this is a lot of information.
It is. Right now we don't have
okay.
information. We did have one viewer who wanted to know if we're doing tours right now at the station, and I did respond to him and let him know that unfortunately right now we're not.
Right now with everything going on, we don't even have all of our employees back here right now. So.
Right. So
All right. Well, thank you guys for joining us for World of Weather. And if you have any questions, just put them in the comment section. And I believe tomorrow the topic is, what is the topic tomorrow? It's something that has to do with behind the scenes. Chief Meteorologist Jennifer Valdez is going to be doing it tomorrow. I think she's showing you how she broadcasts and how she's doing it from home, which is a really cool thing right now because you don't get to see that often, that kind of behind the scenes. All right, so you guys have a fantastic Tuesday. Stay dry, stay healthy, stay happy, and I hope you guys have a great week.